You're listening to Climate Champions, a podcast from the Architects Journal. I'm Hattie Hartman, Sustainability Editor at the Architects Journal.
And I'm Hattie's co-host, Joe Jack Williams, Head of Regenerative Strategy at Bywater.
This episode is supported by Built by Nature, an Amsterdam-based nonprofit with a mission to lead a global transformation of the built environment by accelerating a responsible use of timber and bio-based materials. Built by Nature recently launched 5 principles for responsible timber construction, which we discussed in detail in episode 59. These principles offer a really useful framework for thinking about how to use timber in the built environment without unintended consequences. Find out more at builtbn.org and check out the Built by Nature Knowledge Hub, packed full of resources for designing and building with timber.
Timber has always been the third material, if you like, behind concrete and steel. And I think we've got to a point where we actually do have the answers. And now we need to celebrate. Actually, it makes people feel better to be in these environments. We've reached that tipping point now where we can actually just talk about the joy of being in lovely natural environments.
Our guest today is Kirsten Haggart, Associate Director and Head of Research at Waugh Thistleton Architects. Waugh Thistleton was AJ 100 Practice of the Year in 2023 and is a 25-strong practice based in Shoreditch, London, that will be familiar to many of our listeners for its pioneering work in mass timber construction over the last 2 decades. We're recording this episode off the back of Waugh Thistleton's Black and White building winning global recognition as a winner of the Built by Nature Prize. In this episode, we start with some overarching questions about designing with timber, and then we'll hear about Waugh Thistleton's research and consultancy work, which is led by Kirsten and is a key thread of the practice. We'll also hear about work in the pipeline, twin office buildings on site in Milan, and in a new departure for Waugh Thistleton, a stone-clad office tower in Maidenhead, as well as a collaboration with community housing practice We Can Make in Bristol. Kirsten, you've been at Waugh Thistleton for more than 20 years, with a 5-year hiatus when you were self-employed. You describe yourself as creatively minded, collaborative, and commercially savvy. I look forward to hearing how that plays out in practice. It's great to have you on the podcast today. Thanks for making time with so much going on.
Thank you very much.
You have a long track record and a deep knowledge of designing with timber. What's your advice to practices that are just getting started on this journey?
The first thing is to really inform yourself about the material. We've seen lots of cases where people try and convert a concrete or steel building into a timber building, and that's not the way to go about it. And there's lots of really great information out there, really accessible, from the Mass Timber Insurance Playbook to a couple of things. We did the New Model Building Guidance and the Commercial Timber Guidebook. And then there's lots of international guidance from Swedish Wood to TD UK. It's really important to educate yourself. It's really important to also have collaborations, if you can, early stage with the suppliers as well. That's a really top tip.
So this kind of early engagement, that means you're designing based on what's out there rather than doing your design and then trying to find the timber that suits your design?
No, it would be more to talk to potential suppliers or the installers that you're going to be working with. There are about 5 in the UK who are very knowledgeable. And if you do some early stage design, obviously you want an engineer who has worked with timber before. Then once you get to stage 3, RIBA stage 3 of the design, if you can persuade the client to engage a subcontractor early so that you get that information early into the optimization of the design, that can be really helpful. For example, on that Maidenhead project, we managed to get some input from a supplier actually during stage 3 and simplified the solution quite dramatically, saving quite a lot of money as well.
Do you think, Kirsten, you're able to look at it at stage 3 because you already know how you're designing buildings in timber? And do you think other practices should probably start thinking maybe they need to engage supply chains earlier at stage 2, or do you think there's enough guidance out there to get them over that kind of initial design hurdle?
I think if you can get that guidance earlier on, it's really helpful. But alternatively, if you've got an engineer that has worked with timber before, that can expedite or kind of inform the process a lot more. I think there's other things like, making the design as simple as possible, making sure everything stacks up, not having lots of cantilevers or transfer structures within the building is really important as well, because otherwise you either end up introducing more steel or you end up with really large beam sizes. We're designing with timber to be more sustainable, but we don't want to design just to include loads of timber. And it's really important to optimize that and make it as efficient as possible.
So can you describe for us a little bit Wall Thistleton's journey? How did they get started with timber? And maybe you can mention a couple of defining moments along the path.
Back in the day, before I joined Wall Thistleton, it must be like 23 years ago, Andrew and Anthony designed a little extension to a members club near Waterloo. It was a really tight site and it just took a weekend to install it. And that was part of the reason for using it, just the speed of installation. So you didn't need lots of road closures and things. And then I think Andrew was so enamored with the material and the process of procuring it, of how it was manufactured, off-site manufacture, all the windows and openings pre-cut into the material. It made it really simple. So then I think that was the light bulb moment for him to then think about doing larger projects in it, which hadn't been done anywhere else in Europe. But we had the opportunity to work with Telford Homes on the Murray Grove project. And I was actually the project architect on that. So that had a concrete plinth. It was 3 floors of social housing and 5 floors of private for sale. And it was very much a honeycomb structure. And looking back now, it was over designed because there was a lot of caution around the structural integrity of it. That's where we started to realize the benefit of not only the efficiency and the speed of construction, the fact you don't need such deep foundations when you're building in timber because it's a much lighter weight material. But then we started talking about embodied carbon, which back in 2009 wasn't really...
Nobody was talking about that. No.
No. So I think we were really pushing hard for talking about embodied carbon at that point and have been since then. We are in a serious climate crisis. So we really do need to make some big changes in the way that we build. But then from Murray Grove, there were a number of projects along the journey. We did a project which was a retrofit, where we did a timber extension to the rear and the top of the building. That was the greenhouse on Cambridge Heath Road. And then from there, the black and white building has been almost like the culmination of all the research and experience that we've had over the years, because on that project, we moved away from a platform construction CLT, which means, you're just building everything, walls, floors, everything in CLT, to a more post and beam solution. And there were a number of reasons for that, but importantly, it's about the efficiency of use of the material. But also with black and white being an office, we needed large spans, etc. So we used an LVL frame for that, laminated veneer lumber, with CLT floor plates, CLT core, and then we had a timber curtain walling system and tulip wood facade. But we brought in lots of the experience we've had from other things. For example, we worked with an environmental consultant, urban systems design, Klaus Bode, on the Bergen Trenetia project in Norway. He encouraged us to think about that environmental context piece. It really brought home how it's so important to understand the orientation of your building, to understand the impact of different window sizes depending on the orientation, so that you can then optimize for sunlight and daylight. The depth of the plan can be optimized for natural ventilation, which all together sort of also reduces the energy in use as well.
Just thinking about the black and white, obviously you used LVL rather than glulam, and you talked about moving away from CLT. How much of that came from working with your supply chain? Within the UK, we don't use LVL particularly much. It's not a kind of typical material.
We are very engaged with the European supply chain, with Stora, with KLH, and others over in Austria and Germany. So we're always exploring what new products are coming online. When we built black and white, LVL and glulam obviously had been around for a while, but we visited the Pollmeyer factory where the LVL came from. And I think what was fascinating for us really is again, it's about understanding the material. So for an office building, obviously square meter area is crucial. And although there's a reduction in the cross-section of an LVL column compared to a glulam one, it's much smaller because it's much stronger. Glulam is where you get thin planks but glued together, whereas for an LVL beam, they actually sort of put the log on a spiralator, I think, where they kind of...
It's the best machine I've ever seen. I saw one turn a log into a thin sheet in, I think it was about 6 seconds. It was wild.
It's incredible, isn't it? And so they sort of create these really thin 5mm layers, and then they glue all the layers together to make the column. And it's actually, you get a lot more from the log than you do with glulam. We were just really keen to, obviously from the client's perspective, optimize meter squared rates, and also the floor to ceiling height, as we all know, is very important in commercial buildings, because if the deeper your beams, probably the bigger the facade, and it all impacts the overall cost of the building.
So it was a kind of case of working with that commercial savviness. We talked about that. But understanding that commercial savviness, and then understanding what kind of new materials are out there and products, and sort of seeing a bit of an opportunity. Okay, it's really interesting.
So I had a question about the black and white building. I read in one of your publications that it contains 227 beech trees and 1,547 spruce trees from Germany and Austria. So I was really curious, how do you know that?
So we are very close to the supply chain. So we know the manufacturers, we know what they're... So they if you've ever been to a sawmill, they have all these trees piled up in the backyard, and then they come through the factory. Yeah. And they know exactly how much of the tree they can use for... Because they use as much of the tree as possible, obviously. Yep. But not all of it can be used for CLT and LVL, because trees are round, and construction elements, they're not round typically. So there is a bit of wastage, which either goes to wood fibre insulation, or it goes to heating the factory, or whatever. But so we know how much wastage there is from a tree, and then we can calculate from that the number of trees it took to make the material that's in the building.
I imagine most of your timber's from Europe. Obviously, there's bits and pieces of tulip wood. How, and you say you're really close to the supply chain, so you're talking to the manufacturers. And how does that factor in when you think about how sustainable the forestry is? Are you going to look at the forests as well, or are you looking for certain certificates, or where are you digging for that information to ensure that you've got that kind of idea that it's not just a product, but it's a kind of whole supply chain that's sustainable?
We did actually do an office trip a few years ago to one of the CLT factories. And we went up into the forest on this sort of forest track with a big steep drop on one side. It was slightly terrifying. Anyway, but in Austria particularly, they have huge amounts of forest, but they don't clear fell. They actually pick out the trees that are ready to be harvested and then replant the trees. That doesn't happen everywhere because sometimes it's not viable, but that was a really eye-opening moment for me. Obviously, there are examples with rainforest forestry that the certification isn't always giving the right answer. So I'm confident in Europe we are being as sustainable as we can be, but we haven't used any timber from those sorts of regions.
Are those some of the products that you wouldn't look at as a consequence just because you find them too risky? Or I'm just thinking, obviously, that there's, there is a need for a certain amount of forestry in these places because it provides an important income. But do you feel it's just too risky at the minute to kind of specify those?
Yeah, we would avoid specifying those as much as possible. And the EU is very good at setting out criteria for how to sustainably manage agriculture, and actually is going beyond what FSC are requiring. And then that sort of opens the discussion around more biodiversity in forests as well.
What about the whole issue of local sourcing and minimizing transport emissions? And where do you see the kind of status of more timber being grown and sourced from the UK?
So a lot of the UK timber is structural class C16, whereas the European timber is C24. And a lot of engineers specify C24 and that rightly so, because it's basically stronger than the UK-based stuff. So we need to use it appropriately. Again, it's about understanding the material. And people like We Can Make through their Multimax system. And also there's a lot of great work happening in Wales. Gary Newman from Wood Knowledge Wales is doing a lot of really good work around housing and using homegrown timber from Wales. I think it really suits lower rise solutions. So single family houses, row houses, anything sort of under 3 stories, I'd say, because of that structural difference. There's a real benefit to using more homegrown timber, just not only because of the transport piece, which for me, if it's coming from Europe or it's coming from Inverness, the distances are pretty much the same. So for me, it's how you define local as well, to some extent.
Yeah.
But if we can use more UK-based timber, then that will also support more tree growing. And that can only be a good thing for absorbing CO2. And it kind of links very nicely with the Timber and Construction Roadmap, which the government released they did a revision of it last year, I think. But that's looking at the whole supply chain. And I think that's really, really important, because if you're we want to grow more trees, but we can do that for biodiversity reasons and growing our forests and the kind of amenity of that. Trees don't last forever, like pine. After about 60 years, they stop absorbing carbon dioxide. And so at that point, it makes sense to cut them down and then use them for other things. And so by kind of having more local construction as well, that also enhances the green economy and the local economy, and which is what Melissa from We Can Make is aiming to do, to create these small pockets of fabrication of homegrown timber and therefore homegrown homes as well, involving communities in that process, helping them to understand the connection between the tree that's grown and the house they live in.
I think Kirsten kind of hit the nail on the head, is that actually it's not as clear cut as it perhaps looks. So things like shipping something on a container ship is 200 times more efficient than putting it in a lorry. So all those kind of distances, it might seem like it's traveling a big distance, but in terms of carbon emissions, it's quite an efficient way to do it. So it's not always so clear. And when we talk about locality, it's probably not so much about the transport emissions. It is about the social side to it as much as anything. It's about valuing our forestry. All of these things I think are really interesting, but they're only really doable once you've got an idea of where your material is coming from and what that material is and how you use it. So it's about understanding that whole supply chain.
I think also, it's an interesting point about understanding the material as well, isn't it? That you need to understand the logistics of how it can get to site. I mean, typically panels are 13.5 meters long, something like that, maybe a bit longer. So they do fit on a normal low loader, if that's what they're called.
I wanted to mention one study that Built by Nature supported, which I think for me was really helpful in understanding supply chains, the impact study, where they've taken 10 buildings across Europe and they actually mapped and traced all the steps from the forest to the sawmill to the supplier. It's much more complicated than one thinks. And it's really interesting to see it all spelled out that way. So I guess we need more of that.
Another, just a brief point about the homegrown timber is that a lot of it at the moment is used for fence posts and pallets, the Scottish timber. And actually, the sawmills get very good returns on those products. So there's not really a big incentive for them to supply to construction. However, TDUK said the other day at the Built by Nature conference that there's a lot of research going into that and how to work from both ends, to work from the supplier side as well as the specifier side, to make sure that gets more joined up and it creates a demand that has equal value to what they're already supplying.
It makes so much sense. I mean, we've gotten into these global supply chains and, if we can move back to more local. But yeah, it takes unraveling all the way we've been doing things now for several decades.
Yeah.
So I had another question that came up at the Built by Nature conference, which we're recording just a week after. There was a lot of discussion about the problems with moisture in timber, almost even more so than fire. That was coming on my radar. What observations do you have for things people need to look out for in terms of avoiding problems with moisture?
So we've done a lot of work with insurers who are particularly concerned about fire and moisture in timber. The Mass Timber Insurance Playbook is really useful for understanding how to engage with insurers, but also the Commercial Timber Guidebook looks in depth at those two key areas, the moisture management on site and during the lifetime of the building. Two very different things.
Yes.
But you're absolutely right. The concern is way more around moisture than it is around fire, although both are equally important. So there's lots of guidance out there about how to manage moisture and water during construction and when the building's finished. The moisture management strategies for on-site, they can range from putting a tent over the whole building. But if you don't do that, then it's all about testing. Timber can get wet, but it has to be allowed to dry out before it's covered up in any way. And so it's really important. We have now a moisture management plan that we put into all our tender documents that contractors have to say that they're going to comply with, and they need to produce their own as well. And I think because insurers are much more savvy about these things as well, they are interrogating those documents a lot more at that tender stage. So there's stuff you can do on site to make sure that it never, or by the time you're covering it up, it's not wet. For example, water cut-off valves are very important. Sensors are becoming even more integral to buildings, so that we've got a monitoring system in place should there be any leaks. If we're designing a flat roof, we would only do it with joisted construction rather than CLT, because it's much easier to see any leaks that come through that if they happen. Similarly with bathroom floors, using joisted floor construction there as well, so that the issue with CLT is that it takes a long time for the signs of moisture degradation to come through. And so trying to avoid that is really important.
I think there's something really interesting about building timber buildings is you've got to be sort of in the detail all the way through and thinking about these bigger issues. I presume that kind of extends into repairability as well. So actually, one of the things we heard at Built by Nature is it's easier to repair. I know I've heard stories of people fixing things with chainsaws, going and chopping panels out. Is that something you're designing in, and how do you design for that kind of repairability? And can you say anything about how it compares with other materials as well?
It is relatively easy to repair. I think also if we're thinking about circularity, what we typically do as well is to not have any wet trades in the building. You can take up a raised access floor or whatever and get to any problems a little bit more easily. We've come across cases where that exactly as you say, Joe, no, you take a chainsaw, you cut out the rotten bit, and then you put an equally the same size piece of CLT back with some steel plates kind of connecting it all together, and it's good to go. You can also replace lamellas depending on if it's only a small amount of moisture damage, you can actually take off the top lamella of a CLT panel and then replace that and glue it back in. So it is relatively easy to repair. What we're about is ensuring the longevity of a building. That's so important, so we don't end up replacing things endlessly. So really thinking about how we can make this building last for 100, 150 years or more is key to the design decisions that we make.
Taking that a bit further, then presumably that's talking about end of life of the products as well, as much as anything. So, is it repairable? Is it demountable?
Yeah.
What is that kind of end of life, and is that something you're actively designing in?
Yeah, one of the pieces of research that we're doing, which is funded by the EU, the Horizon project, and we're working with the Danish Technical Institute on, is called Wood Circles, which looks exactly at that, looks at the circularity of timber buildings. And our work package as part of this is thinking about demountability. And what's fascinating about it is the idea that it's not just about thinking about the end of life, it's thinking about the journey the building is on throughout its life. So how do you make sure that the thing you're designing it for today may not be the thing it needs to do in 50 years' time? So making grids really simple so that you can vary layouts. You have soft spots in the building so that you can connect between floors if needs be. So that adaptability piece is part of the puzzle. But then, yeah, obviously the connections and how the building goes together, whether they're bolted rather than nailed, is important. Is a really good example of how to do that. And using dry trades as well, so that you can take the layers off. Some things have a shorter lifetime than others, and obviously structure is the part of the building that lasts the longest. And so thinking about all those other layers that make up the overall building is really important as well, how they can be easily taken apart.
Have you done much about how you represent that and make that intelligible for future generations? I always laugh when people say BIM's going to save the world. When I know full well that I've got BIM models that are 10 years old that we can't open anymore. So, what's going to happen in 56 years? I just wonder if you started to look into that at all.
That's part of this study, actually. And we do look at BIM. There's data within BIM already that describes the product. But how do you then add to that? How do you demount it? But crucially, one of the most useful things from the study is thinking about how you make it really obvious to anyone that's coming to the building to look at taking it apart or demounting it. I think the other big thing is where does this material go after it's been taken apart? We don't have the infrastructure in place to be able to. At the moment, it's about a one-to-one reuse. So there's a host building and a donor building, and if you hit the sweet spot where those two things can go seamlessly from one building to another, brilliant. That's the holy grail. But what this piece of research is looking at is how you kind of make that more sophisticated. So ideally, the products go back into the supply chain, the normal supply chain, and then onto another building. So it's not sort of a direct connection between two buildings. And what we're seeing is the most likely solution for that is that products go back to their manufacturer. I think this is going to be one of the easiest ways to make sure that this circularity happens. Stora are already looking at it. They've made a recycled CLT panel, or Velfac are already taking their windows back and reusing them. I think if the supply chain steps up rather than it going via waste centre or whatever. It's better that it goes back to its owner originally. And then that also raises all the questions around, do we lease materials in buildings and what does that mean?
Well, that's a perfect segue into kind of the whole topic of research within your practice. Tell us a little bit about how big your team is, the role of research, other work you've got going at the moment.
It varies. It's quite small, 3 to 5 people in the practice, led pretty much by Raimondo de Cole. And then Rebecca Saucer as well is another key member of the research team. And it started really with the Build in Wood project, which again was with the Danish Technical Institute. And it had about 26 partners across Europe. And it was an EU-funded project as well. So that was really the driver, that the EU wanted to see how we could increase the amount of timber in construction across Europe. So the project was looking at a system design that could be used in all jurisdictions around Europe for all typologies, from commercial, residential, retrofit. And we designed a post and beam system, CLD floor plates with a non-structural facade panel. That was the little bit that we were doing. It was a 5-year project and it finished a couple of years ago now. But on the back of that, then we did another bid with the Danish Technical Institute for the Wood Circles project, which I mentioned, which is around circularity of timber. It's not just looking at a system design that is adaptable and demountable, but there are other work packages, such as the Technical University of Amsterdam are looking at the urban sawmill, this idea that we have an urban forest just waiting to be harvested, and then where does it go? And can we take that timber from the urban forest and put it through an urban sawmill? They've done lots of research into waste material, which there is a huge quantity of waste timber that is just getting burnt. There is so much potential for that to be reused. Also, it links as well to our earlier conversation about sustainable forestry. It's not, we want our forests to be sustainable, but we also can supplement the supply with waste material as well. So it's an exciting possibility. And then we just won another piece of research called Timber House with the Danish Technical Institute. Our particular piece is looking at health and well-being in buildings, and also looking at the vernacular and how we can learn lessons from vernacular design. Just on the health and well-being piece, at the moment, is measured sort of in terms of what are the OCs, is there toxic off-gassing, is there, what's the temperature, what's the humidity? What we're finding is there's lots and lots of research around our cognitive and physiological response to bio-based materials, and just the fact that seeing more natural textures can actually reduce your stress levels, and it increases your sort of sense of empathy. People are doing sort of studies with these sensors on your head where you can see what parts of your brain are activated by bio-based materials. There is something about the familiarity of that creates that response. We've only been living in a post-industrial world for a really short time compared to what happened before, where we were in a more natural environment.
It's such an important thing.
Yeah.
I always remember reading a great paper from the 1970s where he talked about the great artificial lighting experiment. We just put loads of artificial lights in buildings. We had no idea what the impact is, and we've never really got to the bottom of it. And we're only now starting to unpick things about, circadian rhythms and this kind of thing. And I suspect it'll be exactly the same in the materiality around the buildings that sit around us.
Timber has always been the third material, if you like, behind concrete and steel. And I think we've got to a point where we actually do have the answers for a lot of this. And now we need to celebrate. Actually, it makes people feel better to be in these environments. We've reached that tipping point now where we can actually just talk about the joy of being in lovely natural environments.
You're obviously doing an awful lot of research, which is fantastic. And it's really great to see an architectural practice really pushing this forward.
It really is, yeah.
Are you seeing direct links into your work? Is that where you're seeing the benefit?
We always make it really applied. We try and make it really grounded in reality, because being a pragmatic architect, that's what we have to do. But yeah, so the consultancy has been a good vehicle for us to start to use the research to support others in developing their own projects who maybe haven't got that in-depth knowledge. And we do things like audits of the viability of timber on a project. We'll look at detailed design to see if some of those mitigating measures for moisture damage or fire have been incorporated.
And how much of that consultancy work sort of forms part of your practice? Is it a sort of a significant percentage? Is it a growing wedge?
Yeah, so the architecture is the biggest part of what we do. And then the consultancy and research are quite equal in terms of the amount of time we spend on them. There's so much interest, from whether it's Network Rail or the DFE with their Gen Zero project, or large developers like the Wellcome Trust looking to build more in timber. All the big developers are doing lots of their own research as well into how to develop systems. The change in the last, I'd say, 5 years has been
across
incredible.
The profession,
really.
I agree. Andrew sent me the LCA report kind of that you did about the black and white building, which I found really easy to digest, full of lovely pictures and explanations. But at the back, there were all the EPDs and everything else. I imagine most LCAs are rather inscrutable. I was wondering, we need more of those. I've been looking at buildings for more than 15 years, trying to figure out, how sustainable is this? And, that document was just so helpful. Do you see a demand for kind of other practices wanting to do LCAs in that way?
We have been asked to do LCAs, not for other practices, but for organizations that are looking to define their embodied carbon. And I think for us, the reason we did the black and white LCA was exactly the reason you described, that what is the data behind. They're only as good as the data behind them. And so really, we have a responsibility to make sure the data we're putting in is as accurate as possible. And therefore you get the best results, and you can be really, really transparent about the information you're giving. I think that's, we all want to avoid and make sure that we're clear. And one of the things that we found through that study was that to get EPD data on mechanical and electrical installations is actually the hardest part, because they're usually comprised of multiple different components that come from all over the world, and it's really difficult to get accurate data. So if there are any services people out there, some kind of clear data on M&E products.
The LCA reports that are good are written for designers to improve and understand it. They're not just telling me it's 200 tons or 3 million kilograms of CO2. They're actually trying to provide the information so that we can improve. And I think that's where the LCA analysis at black and white is so intelligible and so engaging. So it's a really interesting subtlety that designers trying to present this information have a much better understanding of what it means. It's not just a number, it's a system, it's a thing, it's a product, it's the MEP systems that we can't sort of semi-unknowable. So yeah, I think that's where I see it as a fantastic report.
Architects are in a position to influence that, to present them in a way that people can understand, because you need to communicate to clients as well as to the consultant team. It would be a great thing. We are going to need to wrap up, Kirsten, but I want to hear briefly what work you've got in the pipeline.
Yeah, so we've got the Maidenhead office building that we're doing for Hub at the moment, which is a LVL frame with CLT floor plates, and it's got a stone facade.
Where does the stone come from?
I had a fantastic trip to Portland Quarry in Dorset. They've got these kind of chainsaw things that are huge, like 3 meters long, that just slice through like butter the stone. Anyway, so what we're using, brick stone, because a lot of the stone that is produced from Portland, people want it to be as pure as possible with very little veining. And so if you're using it in a smaller format, it doesn't matter so much about
Uniformity.
the veining and things like that, the uniformity, exactly. And you can use different batches as well. So you can mix different stones from different seams within the quarry, and get different coloration, as long as it's kind of mixed in the way that the bricklayers lay it. So that's really the main reason we're using it.
Better for the quarry, it's better for everybody. You know, again, using that local material. That's
Yeah.
really exciting.
Yeah. And then we've got in the US that we're working on. Yeah, there's a lot of interest in the US actually. And maybe I'm on an HR network as well, and there's a lot of practices that are looking overseas for more work as well, because it's a little bit suppressed in the UK. So we've got that, and then we've got the project for Lend-Lease at Mind Milan. That's, I think it's 8 stories, office building, which is a glulam frame with a rib floor plate. A lot of effort went into designing the system, because Lend-Lease are developing 1 million square meters on the old expo site in Milan, and they wanted to develop a system that could be applied to all the different typologies that they've got there, from residential to commercial. They've got education facilities as well. So their goal is to build as much of it in project.
The Weekend Make, tell us briefly about
That was a really interesting project for us to work on. And Melissa, she sees that the way that housing is delivered at the moment is not delivering the kind of housing that we actually need. So the social housing, she's addressing it head on. So she's looking at local supply chains. She uses the block build system, which is all made from homegrown UK timber.
Local manufacturing.
Yeah, so that improves the social impact of the work that she's doing. And also, she gave an example where they'd had a years long of consultation with a community group to develop the houses. So she gets real buy-in and genuine buy-in from the communities.
Fantastic. Well, before we wrap up, I'd like to ask you something that I ask many of my guests. So I spotted that you speak Danish, and you had spent a year in Aarhus while you were doing your degree at Nottingham, where I've been doing some critting and teaching. And you spent a couple of years at Mole Architecture before you joined Wath Iselton. So was there a light bulb moment when designing within planetary boundaries became central to your thinking?
So my dad actually was he made exhibition stands for Hepworth and Barratt Homes and things, and would make and so he had a carpentry workshop in the back of his factory. So I would always go in there, and I loved the smell of sawdust, and that's a really early memory from me. I was also very lucky to grow up in a mid-century modern Scandi designed house in the middle of a forest. So I think actually it's been since I was a child that I've loved nature. And then at university, Robert and Brenda Vale, who were our tutors, who were very obviously focused on sustainability. And I remember going around to their house, and they had a composting loo, which was and the whole house was passively designed. They talked about, getting extra pets to heat the house. I loved my time in Aarhus, because that would just suddenly opened up a different way of thinking about architecture, and actually it coming from the individual rather than from a little bit more of a looking at your tutors to give you guidance. It was very much a supported way of designing, where you were kind of encouraged to bring your own ideas, and that was really validated. And I found that really interesting, and kind of made me think, oh, actually, there's something that I can bring to this. And then I loved working with Meredith Mole. I think he has a really special attitude to sustainability and joy in architecture, because of the colour that he uses and the materials. And then obviously starting working on Murray Grove opened my eyes to the engineered timber world, which I've been in ever since.
That's a great place to stop. Is there anything we've missed out?
Just another piece of research, which I think will be really important, is this using wood well piece that we're doing, which is also funded by Built by Nature, but led by Adrian Campbell, who's ex-Arup. And that's about efficiency of timber usage. So thinking about the volume of timber per square meter of building, so that we're really understanding that people are using the material as efficiently as possible.
Thank you very, very much, Kirsten. Great to have you on.
Thanks, Kirsten. That was great. Really
Thank
informative.
you.
Thank you.
Our next guest will be Anna Belizario, Head of Business Development at Urban, based in Sao Paulo. She holds a PhD in mass timber structures from the University of Sao Paulo, and she has been a judge for the Built by Nature Prize for the last 2 years. This episode is supported by Built by Nature, an Amsterdam-based nonprofit with a mission to lead a global transformation of the built environment by accelerating a responsible use of timber and bio-based materials. Built by Nature recently launched 5 principles for responsible timber construction. The principles offer a really useful framework for thinking about how to use timber in the built environment without unintended consequences. Find out more at builtbn.org and check out the Built by Nature Knowledge Hub, packed full of resources for designing and building with timber.